Welcome you all to the next video lecture of the electrostatics, that is electromagnetic fields. In this video lecture we'll try to see the electrostatic concepts. Okay, in the upcoming videos we'll try to see the concepts of electrostatic fields and related laws. In this video lecture I am going to explain the very important electrostatic laws, that is Coulomb's law, and further upcoming videos will try to cover the Gauss law, which is interrelated to this one. Okay, both are interrelated. So let us see the importance of this electrostatic fields in our day-to-day life. So electrostatic fields are very important in our solid state devices like resistors, capacitors, active elements like BJTs and the transistors. So not only in solid state devices, these electrostatic fields are going to play a vital role or important role in the computer peripherals like printers, LEDs and so on. Not only in the computers, these electrostatic fields are very important in the diagnosis, medical diagnosis, like the electroencephalographs and ECGs, and in order to view the internal organs of the body and so on. Similarly, these electrostatic fields are also important in the industrial side like spray painting and so on, that is in baking of meat and so on. Okay, so that is what the importance of these electrostatic fields in our day-to-day. We are having wide range of applications, so I can't give the entire list because it will make the video very lengthy. So let us start our today's topic, that is Coulomb's law. Coulomb's law and electric field. So what this Coulomb's law states, let us see in detail. Okay, Coulomb's law is a experimental law given by Charles Augustin de Coulomb, who was then the colonel in French army. So it was named Charles Augustin de Coulomb was he was one of the colonel at the time of French army. So he has given this experimental law. So let us see what this experimental law states in detail. So this Coulomb's law state actually Coulomb's law actually gives the force of attraction between the point charges. Okay, point charges, we have to note a very important point here, that is point charges. Basically this Coulomb's law is going to focus on the force of attraction. How this force of attraction, that is one point charge is exerting force on another point charge. So here point charge mean that, let us, if I take the point charge as Q, this point charge is having very, very small dimension. Okay, relatively very, very small. Okay, so the dimension is very small. We can say a negligible means volumeless radiator also we can say, which we don't have any volume, which we don't have any size. So that's why it is a small, very small. So the point charge is having volumeless. It don't occupy any space. Okay, So here point charge means it is having negligible dimension, we can say, okay. And this point charge q is exerting, I mean this Coulomb's law states that the one point charge exerting force on another point charge, okay. Here this charge is measured in coulombs. So the I mean the units for coulombs is, so the charge is coulombs here, and 1 coulomb is equal to 6 into 10 to the power of 8 electrons, which is a very big unit or big number, and 1 electron is equal to minus 1.6 into 10 to the power of minus 19 coulombs, okay. So now you might have got the basic concept what actually the Coulomb's law is going to I mean focus, okay. Coulomb's law is going to give the force of attraction that a point charge is exerting on another point charge. So here we need to understand what actually the point charge means. Here actually I have given the point charge is nothing but which is a volumeless which is not going to occupy any space here. Now let us see the basic statement, okay, statement of this Coulomb's law. This statement is given in 3 terms, okay. The force of attraction, Coulomb's law states that the force of attraction between two point charges, we need to say, we have to be specific, that is point charges here, 2 point charges q1 and q2. So the statement here is as follows: the force of attraction between the 2 point charges q1 q2 is along the line joining between them, along the line joining between them, and directly proportional to the product of charges q1 and q2, inversely proportional to the square of the distance between them, square of distance r between them. Suppose if we consider r is a distance, so we may take r as a distance between the 2 point charges. Suppose these 2 point charges are, suppose if I take a point charge here q1 and q2 like this, so if I take a line, so it can be any type. So if I take like here and here, it can be the line shortest possible path here q1 and q2. So I am taking the distance between the 2 point charges as r, and this is q1 and q2, and this Coulomb's law states that the force, it is going to give the force of attraction between the 2 point charges, that is along the line joining. So the force is acting from along this line, and directly proportional, that is if I take force, this force is directly proportional to the product of the charges q1 and q2, and inversely proportional to the square of the distance between them, 1 by r square. If I take these two, if I combine these two, I mean forces, I get here as by introducing the proportionality constant k, that is k into q1 q2 by r square. So q1 q2 are the 2 point charges and r is the distance between them, okay. if I take the constant of proportionality k is equal to 1 by 4 pi epsilon naught here. So where this epsilon naught is the permittivity of free space, if I take as epsilon is equal to epsilon naught into epsilon r. So this is a permittivity of the medium. So the permittivity of the medium is given as epsilon naught into epsilon r. Epsilon r is the relative permittivity. Here if I take epsilon r is equal to 1 for free space. So generally we will take the most of the derivation by taking epsilon r is equal to 1 and we will consider that as a free space or vacuum here. Okay. So that here this epsilon will become epsilon naught here, that is 1 by 4 pi epsilon, that is equal to 1 by 4 pi epsilon naught we can consider here. Okay. So here epsilon naught is nothing but the permittivity of free space. It is given by value 8.854 into 10 to the power of minus 12 farads per meter, or we are having another approximate value which is used for problem solving, that is 10 to the power of minus 9 by 36 pi. So both the values we can use. This is the exact value, accurate value, and this is the approximate value. So by keeping this value we can get the value for k as 9 into 10 to the power of 9 meters per farad. So this k value we can also keep here. K is equal to 9 into 10 power of 9 here. Okay. So now by knowing all these, so I think you might have got the idea here. The force of attraction between Q1 and Q2 is exerting the line joining between them, and directly proportional to the product and inversely proportional to the square of the distance between them. Now let us take the diagrammatic view, and we need to, and this is a scalar one, this force what you have got is a scalar one, and now we need to take the vector analysis here. In order to understand that one, we have to take the 2 point charges like this. Let me draw the diagram here, that is, let me take a 2 point charges here. Let me take Q1 and this as Q2. Now I am joining the line between them because the force is exerting, the force is calculated along the line joining between them is like this. Okay, let me take this distance as r, and now let me extend these lines. So here this Q1, let me take the position vectors, and which is starting from the origin O. Okay, so let me take this one as r1 as a position vector and r2 as another position vector starting from origin to the point charge Q2 as r2 and Q1 as r1. Now the force is, now I am going to calculate the force which, that is Q1 is exerting on Q2, that is I am going to calculate the force on Q1 charge due to the Q1 point charge. Okay, so this one is given as like this, that is F12. Now I am going to write the vector forms of this one. In order to write this one, F12 I have to take, that is Q1 Q2 by, so we have got this equation. After substituting this equation, I have not written this equation here, that is F is equal to Q1 Q2 by 4 pi epsilon naught r square. Okay, now I am going to use this same equation in the vector form here. Why? Because these vectors, they are going to have the specific direction, because these vectors is going to give the direction on which side the force is acting. We have to indicate in form of vectors here. So that is 1 by 4 pi epsilon naught r square into AR12. So AR12 is going to give the unit vector along the direction R12. So now I am going to calculate the force Q1 is exerting on Q2. Okay, so that's why I have written F12 here. Now here unit vector is given as, so the distance vector we know, that is if I take the distance vector R12, that is if I take this as bold one, that is R2 minus R1. So this R2 minus R1 is the distance vector. If I take the modulus for this one, I get here as R, that is modulus of this one, R2 minus R1. So if I substitute AR12 as the unit vector is given as vector by its magnitude. We know the basic definition. So bold letters are represented for the vectors and light phase are for the scalars here. So R12 by R. So now if I substitute this AR12 in this equation, what the equation is going to change, let us see here. So that is F12, I can write here like this, F12, this is we have to write in bold form because it is a vector now. So because it is going to give some direction here, Q1 Q2 by 4 pi epsilon naught, and if I substitute this one AR12 is R2 minus R1 by modulus of R2 minus R1 whole cube, because this R is nothing but R2 minus R1. So here this R again, so R into R square is R cube, that is R2 minus R1. Okay, now so this is the force we have got for the 2 point charges, that is the force exerting on Q1 due to the point Q1 charge. So we have to take this equation for 2 point charges. So we have to take some points to be remembered after calculating this force equation. Let us see what are those points we have to remember, and by considering which points or which statements we have got this equation. So worth noting points, for, let me take this as equation 1 for time being. So for equation 1, so here as we have said that the force F12 is calculated on this one to this one, we can take the reverse of this one also, that is F21. So for that one, if I take F12 is the force, that is I can take here as modulus of F12 into AR12, or else we can write F21 modulus minus AR21. So here these two forces are opposite, that is F12 is exactly opposite to F21, or else we can write AR12, that is the unit vector AR21, that is this force, this is the direction AR12 and this is the direction, and this direction is AR21. So these are the two unit vectors for these point charges, which is, suppose if I take AR21, it will give the unit vector, that is the force F21 will give the force that Q2 is exerting on Q1. So that is what the meaning here. This is the first point we have to consider, and we have to take this second point Q1, and that is Q1 and Q2 must be at static. So this force equation what we have calculated, that is equation 1. So these two charges must be at static. So this should not be in motion. That is a second point. And next one is, here the like charges repels, unlike charges attracts. That is like charges repels. So this is a basic one which we know already knows. that is like charges repels and unlike charges attracts. Like this we can say, that is, suppose if you are having plus minus and plus minus and minus and plus and plus, so minus and plus, so suppose these are the point charges, so here this is a negative and positive, so it will come like this, okay, towards, attracts, so this one will be going away. So like charges here are going to repel, this is also going to repel. So this definition, the force equation which we have got, so basically we have to note these worth noting points here. This is the first one, and this is the second one, and this is the third one and fourth one. So we have to take the sign, okay. So sign must be taken here, that is either it is a positive or negative. So for like charges, that is q1 q2 is greater than 0. For unlike charges q1 q2 must be less than 0 here, okay. That is q1 for unlike charges, this is q1 q2 must be less than 0, okay. So these are the 4 points, that is force must be, these are the unit vectors should be opposite, that is r12 and r21 directions are opposite. q1 q2 must be static, and like charges repels each other, unlike charges attracts here, like this, okay. Now this is the force of attraction if we take 2 point charges. Now what will be the case if I take n number of point charges? So suppose if you are having q1 q2 q3 q4 and so on up to qn, large number of point charges are there in presence of the point charge q. So don't forget these point charges, because basically this Coulomb's law is going to is calculated based on these point charges only, okay. Now I am going to by taking the equation 1 which we have calculated recently. Now if we have n point charges, that is, let me take q1 q2 q3 and so on up to qn, okay. And similarly the position vectors for this one as r1 r2 and so on up to rn we have. So now I have to calculate the total force F, okay, that is we have to calculate the total force F. Now in order to calculate this total force F, this equation which we have calculated for 2 point charges is we can extend for n number of point charges just by taking all the forces, that is by applying superposition theorem, that is adding all the point charges. So now if I take the total force F as F, if I take this as F, the point charge what we have calculated till now, let me write that equation here, q1 q2 by 4 pi epsilon naught r2 minus r1 by mod of r2 minus r1 whole cube. So this was the equation here. Now we have to extend this equation for the n number of point charges. So in presence of charge q, so how this force is calculated? q1 will be force exerting on q1, q will be exerting force on q2, q will be exerting force on q3 and so on. So at that time the force equation is going to be changed like this, that is q1 by 4 pi epsilon naught r minus r1 by mod of r minus r1 whole cube. Similarly next charge, that is q2 q charge and q2 charge by 4 pi epsilon naught r minus r2 by mod of r minus r2 whole cube, and so on. If I extend this for then it will be given as qn by 4 pi epsilon naught r minus rn by mod of r minus rn whole cube. Now if I summate this equation, I can make in the compact form, the equation written in the compact form like this, that is q, the common terms are here, q by 4 pi epsilon naught are common. I can take like this, q by 4 pi epsilon naught summation k is equal to 1 to n, here r minus rk by mod of r minus rk whole cube. So this is the equation which I get after calculating the force between n number of, here I had to write qk also. I forgot to write the qk, because if I take k is equal to 1 here, q1 r minus r1 by mod of by r of r minus r1 whole cube, and so on. Okay? So this equation will be giving the same after expanding this k is equal to 1 to n. So this is how we can calculate the force of attraction between q charge and in the presence of n number of point charges. So point q charge is present in presence of all the q1 to qn. So I can calculate the total force by taking the superposition theorem, that is individually calculating the force and summing all those forces and writing in the final form of this equation. Okay. Now after knowing this force between the point charges, our next concept which is ready is the electric field. So here electric field, which is very much interdependent, we can say, okay, which are very interdependent, which are related to each other. So we can state that the electric field is defined as force per unit charge, per unit charge. So basically charge is given by q, and I am going to write electric field with the E here, notation is E here, and by taking the basic definition I can write here as F upon Q, that is force per unit charge, that is in presence of the electrostatic fields. Okay, that is I can also write here as E is equal to limit Q tends to 0 F by Q. Now this electric field is calculated by taking this force equation 1 what we have written, that is this equation. Now by expanding that equation I can write here like this, E is equal to, so one charge will get cancelled here, because one charge, if I take cancel here, that is F by Q. If I take F by Q here, so one charge is going to get cancelled, that is Q by 4 pi epsilon naught r square into AR. Okay. So here if I write, I am going to calculate the electric field for the point charge which is located at r dash. So this will become, this r, AR will become here as r minus r dash. Okay. So and the AR vector will be, unit vector will be r minus r dash by mod of r minus r dash. Okay. So this will become like this here, that is E is equal to Q by 4 pi epsilon naught. This AR is nothing but this one, that is R is nothing but this one. So if I take, I get here like this, r minus r dash by mod of r minus r dash whole cube. So this is the electric field equation for the point charge which is located as r dash. And now if I want to calculate this electric field again for the n number of point charges, so we can extend the same as we have done the procedure for calculating the force for n number of point charges. Similar procedure can be adopted here also to calculate the electric field. So the equation will become E is equal to, for n number of point charges, for n point charges, that is q1, q2 and so on up to qn. So the equation will be E is equal to, this can be kept outside because it is a common term here, 1 by 4 pi epsilon. If I write that is for q1 into r minus r1 minus r1 by mod of r minus r1 dash r1 whole cube. Similarly q2 by 4 pi epsilon naught r minus r2 by mod of r minus r2 whole cube, and so on, qn into r minus in by 4 pi epsilon naught mod of r minus in whole cube. So now we can keep this electric field equation in the compact form, that is summation E is equal to summation k is, so we will take this outside, 1 by 4 pi epsilon naught summation k is equal to 1 to n qk by r minus rk by mod of r minus rk whole cube. So this is the equation which we have got for the electrostatic field, E field, for the n number of point charges. Okay, so now we have got the clear idea about what is actually Coulomb's law and what is actually electric field. Okay, so after calculating the force of attraction between the point charges, 2 point charges, we have extended that to the force equation of 2 point charges to the n number of point charges. Similarly, by using the force equation, we have we know the basic definition of electric field as defined as the force per unit charge. Okay, so if I take force per unit charge, the equation is going to reduce like this. So this is the topic here. So I think it is the concept might be clear here. So we'll move on to the next concept in the next upcoming video lectures. So if you have not subscribed my channel, please subscribe, share it with your friends, and please don't forget to share with your friend circles, and you can like this video. Thank you very much.